Good morning, 8th graders. So we are going to be kind of talking through the 9.6.0 activity, Conduction and Convection Gizmo. So we are going to go through basically this first page together. It's the warm-up, and then we start getting into the activities. I'm going to show you some tips and tricks while using the actual gizmo itself, and then you will have time to complete what you need to. Okay, so remember to put your name at the top of the page as always. And then let's answer some of these prior knowledge questions before we really get into the actual gizmo itself. So, first one, 2 pots have been sitting on the stove for a while. One pot has a copper handle and the other one has a wooden handle. Which handle would you rather touch and why? We are going with the presumption that your hand is not covered by an oven mitt or a towel or anything like that. Just which handle would you want to touch after the pots have been sitting on the stove? Okay. And then tell me your why. This is kind of a personal question. I know which one I would touch, but I'm not sure you. Okay. Number 2. One of the pots is filled with soup. The soup at the bottom of the pot is warmed by the stove burner. How does the soup at the top get hot? Okay, so sorry, I kind of stumbled through that. So essentially you have a pot full of soup. You know that the soup at the very bottom is getting warmed because it's super duper close to the actual burner itself. How are we getting the soup toward the top of the pot as warmed? Okay, so we know, just because this is something we've been studying almost all year, we know that as things get warmed, they start to rise. Okay, and then things that are cooler start to sink. So without even stirring your soup, you know that the top of your soup will get warmed up because we have something called convection, where the warmer soup is going to start kind of raising toward the top and the cooler soup is going to sink down until it gets warmed up. And then it's just a continuous cycle throughout. Okay, so awesome. Let's move down to the warm-up. So we're going to actually get into this gizmo. First things that I want to make sure you are aware of within this gizmo is that you should enter in on the experiment. Remember, it should say conduction and convection. I just have it in full screen so it's easier to see. Okay, so you should be an experiment, but you'll notice that there's also a data. Okay, you're able to zoom in, you're able to zoom out, whatever works best for you. So within the experiment, now remember you also have tools along this side. So if you need to take a screenshot, if you need to drag an arrow, that sort of a thing, that help. Sounds, if you want to turn it off, because I find the clicking absolutely obnoxious, but you do you. Okay, so that is where we're going to be. I'm just going to set this down here because once it's in, it's in. Oh my goodness. Okay, so that you'll notice that you have 2 different temperature readings. They are in Celsius, and you are able to adjust through here. So, and then same with the initial one for yellow, starting at 50, but it could go up to 95. It could go down to 5. Okay. There's also these 2 drop downs, so different materials here, and then whether you're using a hollow pipe or a solid chunk. You have times here where you are able to hit play, jump forward, pause, reset, all that fun jazz, okay? So keep those in mind as we are kind of working through this. So I've reset everything back to 20, 50, copper, hollow pipe, and no time has passed. Okay, so back to this, the warm-up. So the conduction and convection gizmo shows 2 flasks of colored water, one blue and one yellow. Select the copper and solid chunk from the drop-down list. This means the 2 flasks are separated by a solid piece of copper, and the 2 liquids cannot touch each other. Use the slider to make one flask hotter than the other. Click play. See what happens. So First things first, we need copper, but we're not going to use a hollow pipe. We're going to use a solid chunk. Okay. We already have the yellow at 50 degrees Celsius versus the blue is at 20 degrees Celsius. I'm going to make it just a little more like obvious and in your face. So we have 5 degrees, we have 95 degrees. Okay. And then I am going to hit play. So you'll see that the two corks came out and the copper pipe or solid chunk went in. Okay. So I see my temperatures are changing. My time is elapsing. I'm going to just kind of fast forward this. Ooh, now things have started. Ooh, now they've reached the same temperature. So hit play and then see what happens. So what happened? Well, we noticed that our fluids did not mix, but something that started at 5 degrees Celsius is now up to 50 degrees Celsius, and something that started at 95 degrees Celsius is now down to 50 degrees Celsius. So what happened? Our temperatures over a span of time, and let me do some quick math. If we have 858 seconds divided by 60, so this is over 14 minutes, about 14 minutes, 20-ish seconds. So that's kind of significant that it took only that amount of time for things to kind of level out. So what happened? The temperature of both fluids reached a balance. Okay, so I would write something like that on that little line. There's not a lot of space, so just kind of keep it simple. Both flasks got to 50 degrees. Okay, now select the data tab. Sorry, I'm reading number 2. Select the data tab and look at the graph. What do the blue curve and the yellow curve represent? Well, let's take a peek. So we have a blue curve and we have a yellow curve. And the great thing about graphs is that there should always be a key for what each set of data is telling us. So the blue curve represents the blue fluid. The yellow curve represents the yellow fluid. So that's what you would write down for 2A and B. What is the final temperature of the top flask and the bottom flask? Well, final temperature, you don't need to look at this. Granted, you could, okay? Because it shows you over 50 seconds. They start to even out. But if we go back here, the final temperature is 50 degrees Celsius and 50 degrees Celsius. Okay? So, awesome. Now, that is your warm-up. So, when you move into activity A, and there is also an activity B and C, okay? Make sure every time you do that, it gives you a little like quick reset. So I'm going to hit reset on here. I'm going to set the initial temperatures of the top flask being 95 and the bottom flask being 5. Okay. And then you are going to make sure, run the gizmo twice. Once with a solid chunk of copper separating the liquid and once with a solid chunk of stone. So we technically already ran the copper. So you would click stone, you'd hit play, and you would kind of see what happens. Okay. So I'm going to reset that for you. So make sure that when you go through all of that, make sure that you fill this in, form a hypothesis, or remember an educated guess before you really start moving. Of the 6 substances in the gizmo, which one would allow the fastest temperature change in the 2 flasks? You won't 100% know that. That's a prediction. And then you're actually going to test it. Okay? And then analyze and draw a conclusion. I am going to tell you this. I'm looking for the draw conclusion. I want to see, can you form a hypothesis? What data can you collect? And then what did you actually determine in the end? Okay. Same thing goes with activity B. Make sure you reset it. Make sure you do as it says. And activity C. The main thing on here I'm going to be looking for is your draw conclusion, but also extending your thinking. I want to see, can you look beyond just what is right in front of your face? Okay, fabulous. If you have any questions, please feel free to ask your teachers. We're here to help. Awesome. Thank you, 8th graders.